Welcome back to another exciting video here in Workshop Wasteland. Today, we are machining the cylinder head, which turned out absolutely fantastic. I'm super proud of this part. There's a lot of work in this little piece, as you're going to see throughout the video. I did make a pretty critical mistake in the way I was thinking about things, so I'm kind of curious down in the comments if you figure out the mistake that I made before I tell you about it. Let me know when you kind of were like, uh-oh, that's not going to work. He probably should have done something different. I also, when I made this cylinder, I don't know what I was doing, and I left that diameter on there a little bit big, but I fixed that off camera, and the cylinder head fits on there perfectly now. So all is well. Like I said, a little bit of a longer video. Probably ought to grab your favorite beverage and prop up your feet on the recliner and really enjoy this video. I put a lot of time into it. It's a pretty intricate part, and as always, hopefully you enjoy. Don't forget to like, comment, and subscribe. I had planned on making the cylinder head out of this chunk of aluminum, but the more that I thought about it, there would be no way to cut these features on here and be able to clamp it in my lathe. So as you can see here on the plans, you have to cut these grooves in, which of course is easy to do with a parting blade, but there'd be no way for me to hold it, especially to get all of them cut, right? I could get some of them pretty easily. So I came up with a bit of a different solution to this that I hope is going to work. So this is my solution, and this loosely stems from Mr. Joe's YouTube video on making the cylinder head. So this is right now a single block of aluminum, and I milled a flat in it, which is against this vise jaw, and then I laid out my holes and drilled them. I drilled deeper than the thickness of the head with the tapping drill, and then I drilled right to the thickness of the head with the clearance drill, and then countersunk them according to the plans, in hopes that I can cut all of these grooves and features, machine my spark plug pocket here, and then I can flip this around and bolt it back onto this piece. So it may or may not work. I'm not 100% sure. I guess, nothing really to lose except some material in trying it this way. But like I said, my plan is cut all these features in the sides and then part this off after I cut my spark plug pocket and drill for the threads. So we'll see if it's going to work out. I'm going to get this chucked up in the lathe and we'll go from there. Got it chucked back up in the lathe. You can see the flat spot that I machined out, and I made sure to put this flat spot back between the same two jaws. If you watch the indicator, there's very little run out on that part, so we got it at least close enough. There's probably half a thou to a thou run out there, which is more than good enough. And then I can use this flat to be square with the holes that I drilled in the end whenever I put it back in the mill to finish up some of the cuts. So next thing I'm going to do is drill this spark plug hole into this part. So this is a drilling operation, and we need to drill in through this part all the way with an S drill, because we're going to tap it 10mm by 1 for a spark plug. So the head is going to be 8/12 whenever we're all said and done, so we need to drill deeper than that. And I went kind of old school on this, and I marked my drill bits ahead of time. It's definitely not a super accurate way to do this, but the most important part is that I drilled deep enough to get all the way through, but then also not so deep that I'm wasting material on the part that's going to be left over in the end. So we'll go ahead and get this cranked through. It's just drilling aluminum, so it's pretty easy. So that's that hole drilled through. Hopefully my math is correct on all of this. Now we need to make a counter bore in that. 5/8 diameter for the counter bore. So 5/8 is 625. Touch off on the face here. And let's see how deep that needs to go. Interestingly enough, I don't see anywhere where it tells you how deep to bore this pocket, which I guess is okay. We can just kind of wing it, I suppose. So for now, we're going to cut this 5/8 like it says, and we'll kind of go from there. Like I said, 5/8 is 625. So here we go. Give that a quick measure, see where we're at, so we can keep going. We're pretty much 520 right now. Now I think the smartest thing to do is to tap that hole and put the plug in and just kind of see how it looks, I guess. Like I said, I don't all the way understand why it's not called for or not called out in the plans. Unless there's a measurement somewhere that I'm just missing, but I don't think so. I think we'll power tap this with lots of cutting oil. And then we'll thread our plug in and see how it looks. Well, I think that's just fine. What I'm going to do is take a cleanup cut off the base of that hole, because the gasket of the spark plug needs to seal up on that. So like I said, take like a cleanup cut off of this. Alright, now we can double check this with our spark plug. I think that will be just fine. Seems to me like it ought to be threaded in there farther though. But I guess worst case scenario, we can always come back to this exact same setup. You know, we can always clamp it back onto our bar here and do that. So that'll work too. I'm going to get set up for the next operation here, which is going to be cutting those grooves on the diameter of this part and bring you right back for that. Well, this is a brand new to me process. I literally just did a single test cut with this slitting saw. This is a 1/16 inch slitting saw, and I've never really used one before. I've honestly never needed one before. You might be able to get away with cutting these slots with like a 1/16 inch end mill, but they're pretty darn fragile, and I think this is probably the best alternative. So we're going to give this a go. I got the slitting saw lined up by eye as best as I could, flush with the bottom of the part, and we need to come up 62 thousandths to cut the first slit. So I'm going to do that. There's 62 and a half, which is a 16th of an inch. So that's going to be our first slit. What I'm going to do is touch off on this and then back all the way out of the part and move over 171. That's how deep they're supposed to be, 171. And then I'm going to turn this screw in, which is my lock screw for the X-axis on my milling machine. So hopefully this works out. I am clamped on this flat spot once again, so hopefully it'll end up square with the holes that we machined in there. And I guess nothing to it but to do it. Let's see how it goes. Also, the camera's a little bit shaky. I apologize for that. I don't know how much of that shake it's going to get out of there, but it's on kind of a flimsy tripod, trying to get you a decent shot here, so we'll see how it goes. So that's touching. I'm going to back out of my part and zero that and come over 171, which I kind of feel like is a pretty deep cut for a slitting saw, but I could be completely wrong. Like I said, I have no experience whatsoever with these, so if anyone in the comments knows more about it and wants to let me know if this is a pretty normal operation for a slitting saw or not, that would be cool. Because like I said, I have virtually no experience besides a test cut moments ago. So this is kind of new to me. I guess nothing like learning on a pretty important part. Something that has a good bit of time into it, so if we wreck it, that's going to suck, but here we go. I'm going to run this about 950. That's what I was doing the last time. That seemed to work pretty well, so let's see how this goes. Well, I don't know. That seems to have went okay. There's at least a slit cut in there, and it should be 171 deep. So now the fins are, the material that you're leaving behind is a 1/16 of an inch, and this is a 1/16 of an inch slitting saw, so we need to move up 125. 62 and a half and 62 and a half is 125, so we'll move up 125. I'll probably cut one more on camera and then go back and finish these up, only because once you've seen it, you've seen it, you know. So this should be the next fin. We've moved up 125. Here goes nothing. This actually cuts better than I thought it was going to. I figured this was going to be an incredibly slow process, but it doesn't seem like it's going too bad. I don't know, maybe I'm feeding it through a lot faster than I should be or something, but crank all the way out of that once and kind of show you what we're doing here. So there are the slots. Grab my brush here and clean that off a little bit so you can kind of see. that's the slots that we're making. And like I said, it seems like it's working pretty good. So I'm going to cut the rest of these off camera. Like I said, once you've seen one, you've seen them all. So I'm going to cut the rest of these off camera and bring you back for the next operation. Well, as you can see, pop this camera out. Those grooves came out pretty darn good. I'll show you later on the plans. They're actually not perfectly centered on the holes anyways, even on the dimensions in the plans. But overall, I'm really happy with how that looks. Like I said, it came out really almost perfect in my opinion. So now we need to machine a slot down into here where the carburetor and valve assembly and all of that's going to go. And that slot is 3/8 of an inch deep. So off the top, I've already touched off on my tool, centered up on here, you know, from either side. So we need to go 3/8 down, and it's 8:43, 27:30 seconds wide, and we need to go 13/16 towards you, because that's the width of the head, and this is a slot that gets machined all the way through. So my arm's going to get in the way a bunch of this, but I think this is the best place to have you sitting to kind of see what I'm doing here. So here we go. I need to touch off on the face and then start cutting across. So there, I'm touched off on the face. I want to zero that. My end mill looks to be centered above the spark plug hole right now, so I think my indicator worked. So here we go. I think before I make that cut, I'm actually going to take a measurement here and make sure that my math worked out. So we should have 843 wide or something right close to it. We're going to machine a part to fit in here anyway, so yeah, that's good. Okay. My math worked out. That's always good. Alright, I think we got to take about 2 more laps around here. I'm going to leave a nice finishing cut for the end. Give this a quick look, see how it turned out. Looks pretty darn good to me. Let's see, we're set up now. We may as well drill this hole down through here because I've already touched off and I already got a center, so may as well drill that hole. Alright, so that hole is centered up in here. So we'll go ahead and get that. And then it is a 1/4 inch up from the bottom. So we were using a 3/8 end mill when we touched off on here. So that means we need to go 137 in. I'm sorry, 187 in. So 187. If we zero that, that should put the end mill. Yep, there's that. And then this thing is going to be 13/16 long. So 0.812 minus a 1/4 inch. So we need to go over 562. Let's give that a little spot and then measure it. Give that one little dimple there. Grab a scale real quick. Yeah, that math looks like it maths out. So we'll go ahead and drill this through. Move the camera so I'm not having my arm in the way the whole time. That's a 1/4 inch hole, and this really isn't all that critical of a hole, I don't think. Now we'll jam a 1/4 inch bit in that, and then I do believe we're done on the mill with this part. Alright, so that's the 1/4 inch hole, and as you can see I cut past this this real shiny line right here. That's my overall length of my part, and I cut past that so that I ended up with that being squared off. So hopefully that all turned out okay. But like I said, I think that's it for the milling machine on this part. Okay, so I have my parting blade in here. This is the overall length plus 20 thousandths to give me a cleanup cut on the base after I part it off. and I'm getting ready to do these fins. This took a lot of monkeying around to make sure that I was going to do it right. This piece has a lot of work in it at this point, and I'd really, really hate to scrap it on some, basically decorative fins. So hopefully I'm set up correctly. What I did was marked this, like I said, with the parting blade. I moved over the thickness of my blade plus that 20 thousandths. And now, according to the plans, the very first fin is 1/16 of an inch, which means we need to move over 62 thousandths from here. 62 and a half, I guess, really. So there's my 2. And then there is that. And we have to go in 1/4 of an inch on this, which is quite a bit actually. I hope this little kind of crappy parting blade is able to do this. And then I have my indicator set up back here. Once it touches for my 0, then I will zero this dial indicator back here. But we have to go in 250 thousandths. So that's all the way around twice plus half more. This is in back gear right now, so there's a little bit more gear train noise than normal, so I apologize for that, but it just is what it is. I mean, that's close enough. We're 1 thou off of 0 right there. Let me grab some cutting oil for this. I'm going to try WD-40. I just recently read online that WD-40 works pretty good for cutting aluminum, so I'm going to give that a try, see what that does. You don't know what you don't try, so let's give that a try. So like I said, we got to go in 250 thousandths. It's going to be pretty slow. It feels really weird making this cut because of that notch that we cut in there earlier. So it's a super interrupted cut. There's 100 thousandths. Alright, well, that's the first fin. As you can see, that's a pretty tedious process, but that's okay. So I'm not going to record all of these for you. That would be really boring. I'm going to go through and finish these up and bring you back when we get this part swapped around. Alright, so the last operation before we part this head off of our blank is there's a 45-degree, I guess call it chamfer, angle, whatever you want to call it on there. I got my cross slide all set up here with the compound at 45 degrees. So let's see how this goes. It's going to be a really weirdly interrupted cut, so I don't really actually know how good this is going to cut. But we're about to find out. Oh, you know what? Haha. I'm cutting on the back side of the part. I'm an idiot. I gotta run the lathe in reverse. I think I'm going to go just a little bit more on that. Need to try and get rid of the burr that it created there. Alright, this is the last cut before I wreck the part. There is that angle cut. It's purely a cosmetic thing, so at the end of the day it's not really all that important. It's probably not quite as much of a cut as what they wanted you to do in the plans, but that's where I wanted to stop, so I stopped. So the next thing we're going to do is part this off. I may have made a mistake by making it this way. I guess we'll find out after we get it parted off and see how everything works. But my drill bit holes from drilling these should be deep enough in there. In fact, now's probably a really good time to check that. But this should be deep enough to be able to tap my holes then. At least I sure hope so. Maybe not, actually. Yeah, I think we're good. And I guess if not, it's kind of too late at this point. So here we go. Let's part this thing off. Well, I guess this is how you can tell you're an amateur machinist and something's not going to work out, because the next thing we need to do is face this end off and then bore the combustion chamber in like a pocket in there. And in my mind this was going to work, but I can't countersink the screws on this side because then there wouldn't be anything left for the other side. So that's clearly not going to work. It's a bummer because it was a good idea, but at least my holes are drilled accurately, and I guess I'm going to take some like aluminum shim stock and wrap around this and then clamp it in my 3-jaw and probably just not go super hog wild on how tight I make it, and take some light cuts. So I guess I'll bring you back when I'm set up, but it's kind of a bummer. Like I said, I'm just an amateur, you know, kind of learning as I go, teaching myself as I go, and clearly this is not the right move, and that's definitely 100% not going to work. Alright, well, this is our last and final step. You can kind of see right here, this is a piece of aluminum can, and I'm using it to kind of hopefully pad the jaws, that way I don't mess up my finish. If I do, at this point it kind of is what it is. I've put way too much work into this to restart, but yeah, like I said, my plan didn't really go as I thought it would, but oh well, stuff happens. So we have to bore a 812 thousandths wide hole, or pocket, whatever you want to say, and we need to go 375 deep. Over on the other side of my machine here, I have my depth stop set already, so we can just go to town on this, and we need to open it up to 812. Alright, there's our 812. What I'm going to do is skim across the bottom of that. I'm going to move my indicator back a few thousandths. Let's go 3 thousandths. And I'm going to smooth off the bottom, just so like no carbon builds up. It'll probably help with airflow, all that sort of stuff. Now we need to make this little recess for the cylinder. That measures in at 996, and it's about 72 thousandths. Should be real close to fitting. Doesn't seem even remotely close. What am I doing wrong here? It's 996. Oh, I gotta go all the way around yet. I gotta go 50 thou more. Well, when I made this cylinder, I don't know what I was thinking, but I left this little lip that you can see on there way too big. But that's easy to chuck back into the lathe and then align it, you know, so that it fits very nicely into the head. That's how it's going to go right there. So I'm going to stop there. I already made that bigger than what the plans probably wanted you to. I guess there will also be a gasket or silicone or something on there. So really at the end of the day, it's probably fine. Just cut the gasket to fit this. I bet it would work just fine, but this is easy enough to throw back in the lathe and turn that recess down just a little bit. So I think we'll call that good for the head, and that might be the end of the video. We'll have to see if I can squeeze anything else in.